Hey, good morning for the West Coast and good afternoon for the East Coast. We are going to do a webinar today on just setting up a TurnMill machine, just building some tool blocks, putting it in the machine, and from there we'll program a simple part. Hopefully you can find some of the information useful, and if not, let us know what you'd like us to cover in the future. So anytime I'm starting a new file, I always want to go to new, and you can start either default inch or default metric. So we're going to start default inch. From there, my recommendation is that you always pick your machine. So we're going to go to machine setup, and I have a Doosan Puma 2600 SYII we're going to use. This one has a BMT 65 turret, right? So we've got main sub and then a turret with 12 stations plus half stations. Right. From there, we'll hit OK. We also want to add in our fixture or chuck. So we're going to go back into machine setup and we can click fixture right here. We already have a video on YouTube showing you how to create collet chucks, and we're just going to use one of those, specifically the Royal 4600 46,170 right here with the QG80 collet. Right, so we'll select that, and that pops in like this. We'll hit OK. So if you wanted to put it on the sub, you could just switch the mounting from FA1 to FA2. But we're going to just program this in the main right now. So we'll put it on FA1 and hit OK. From here, we need to add our collets. If you haven't decided what size stock you're going to use, you can leave it without collets for right now and add collets once you decide the stock. Right, so I'm just going to add the collets that I know I'm going to use, which are going to be the 3-inch QG80 collets. So there we go. We can hit OK. And you can see that the collets function. Right, and our chuck is in. Right, and again, we have a YouTube video on how to create this exact same collet chuck and the collets. Right. From there, we can turn off the outer body of the machine just so we can more easily see all the internals. You can click this button or you can drag this slider up. Right. From here, we're going to start focusing on building holder blocks for our turret. So we're going to go back to the part view. Right. And I'm going to create a new layer. I'm just going to call it the first holder. Right. And well, actually, we're going to go back to machine setup and tool assemblies, and we're going to load a holder that we made in our previous YouTube video first, which is the double OD holder. And then we'll create some additional ones. So we're going to click on station 1, right? Tool assemblies, and I'm in my machine view so I can see it get added. Right click, add adaptive item, and we're going to choose our OD double turn block. Looks like this. And that mounts to our turret like so. Right, so we're going to make some of those turn blocks just different. We'll hit OK there. So now we're going to go to our part side, and you can switch to part side right here, or you can hit Tab on your keyboard. And we are in the layer first holder, and we're going to go to File, Import. And we're going to start with, let's do a face turn block first. Now, when you're loading a holder you want to make, you do not need to have import as new part checked. What that's going to do is automatically fill your part with whatever you're importing. We don't want that. We're not programming this face turn block as a part. We're making it into a GDML for our machine. So we're going to click open, and that's going to load in. We can hit yes for CAD diagnostics, and it finds no issues. So the holders I'm using automatically kind of come in at the right origin, except for if I look at my XYZ, right, I got Y up, X to the left, and Z to the back. What I always like to do is go to tool assemblies and then click a station that I want to add my tool block to. And I'm going to look at this origin on how the tool block is going to mount to the station. If you notice, I have Y green up, red X to the left, and blue Z to the inside of the turret, right? Well, this tool block, if I were to make it this way, the face holder would be positioned for the sub side. So what I need to do is I need to rotate my part in space against the origin. So that's a really simple routine. So I like to keep my origin how I want it and then think about moving the part against that. So I'm just going to, you can either right click and go to select all to select the whole body. You can Control A on your keyboard, or you can left click on the face and then right click to get the whole body. Then we're going to right click in the GUI right here, the graphical user interface, and we're going to go to copy. Transformation type is going to be rotate. We're moving it. We don't want to create an additional copy. We're just going to move it. Angle between copies is going to be 180. I want to flip it 180 degrees. And we're going to uncheck use origin for rotation axis. What this does, if we had this checked, it would rotate 180 degrees around all three axes from the origin base. We don't want that. We just want to choose one axis to rotate around. So once you uncheck this and hit OK, nothing's going to happen until you choose the axis that you want to rotate around. So we're going to choose the axis that goes straight through the holder. And then you can see that my origin stayed the same, but the part rotated, which is exactly what I needed. Right? From there, the thing I always like to teach is we're going to move our work plane one axis at a time to a specific location and then save that work plane, right? So I'm going to go to manipulation and I'm going to go to modify work plane and I'm going to choose the blue axis, which is Z, and I'm going to drive it to this edge, right? We really want the mounting point to be in the center of the tool, right? But for right now, we're putting it here because we don't have a point to represent the perfect center. I don't know that this point in the middle of this line is perfectly centered between this edge and where the tool needs to be. So I create it on this edge so that the holder rests against that. And I'm going to click the blue axis again. I'm going to type in -0.5. For a 1-inch tool stick, we're going to use a 1/2 inch center point. So that's going to move that work axis or that work plane to the center of where we would put our stick tool in. Right now, I need to move the red axis in this case to the back so that our stick holds all the way to the back. So right there. Now we need to rotate our work plane, right? Because I want Z towards the back of the stick. And if my stick is coming out the front right here, then I want to rotate it -90 around the V or Y. So now red is out. Now, because this is going to use a tool facing the facing upside down, right? We are going to want to flip this work plane again 180 degrees, but around the Z in this case. So we're going to click the blue arc and we're going to type 180, right? So that is our tool mounting position for this face block. This is probably one of the more difficult basic blocks because it's a face tool and you have to rotate it multiple ways. But we're going to click no active work plane at the top right here, and then we can click plus, and we're going to save this as TA1, right? That just means tool attachment point 1. Usually you can also create an HA1 called holder attachment 1, but if you save a solid out as a GDML, wherever you have a TA, SYII will automatically create an HA, right? So once I've got the TA made and the origin is correct, I can just select my whole part, go to File, Save As, and we're going to go, and I'm just going to name this Face Tool Block. Save As type, you need to make sure you set this as holder files, right? That determines how it's saving out of ESPRIT and adds the correct naming inside the GDML and also creates the HA and the TA. Otherwise, that just becomes a work plane called TA and it doesn't actually convert to a tool attachment point. So once we hit save here, I can go back to my machine view and I can right click station 2 and go to add adaptive item and I can mount that face tool block like so. So that's the one we just made, right? So I'm just going to make a new layer. I'll call it second holder. And I'll turn off first holder. Now, a lot of people get confused that it says, well, I turned off first holder, but the model is still showing on the screen. That's because it's still selected. So if I were to click anywhere in the GUI right now with just a left click, it would deselect the item, and that's why it would disappear, right? So selected items still show in the graphical side, even if they're not enabled, right? I also don't need TA1 anymore from the original first folder, so I'll click delete there. All right, for second holder, we'll go to File, Import. And again, we're not going to import as a new part because we're not programming it as a part. And next, let's do a radial offset live tool block. So we'll click OK, and that will load in. No faults on the CAD model, right? So again, I'm looking at it, Y up, X to the left, and Z to the back. If you wanted it to offset towards the sub, this would be a fine orientation. But otherwise, we want to rotate it so that it's offset towards the main. So we're going to right click in the GUI, right? Because the model was already selected. I can right click in the GUI, go to copy, rotate, move 180, and click OK, and then choose the axis by which I want to rotate it, right? And so I can confirm by going to the machine side and then just clicking an empty station. I want Y up, X to the left, and Z to the back. I do that every time I build a tool block, right? So if I were to mount this mentally, that's how it's going to mount, just like that, right? Perfect. From there, all we need to do is go to Modify Work Plane on the Manipulation ribbon, right? And move one axis at a time. The order does not matter. We're going to click the blue axis for Z, and we'll click this front face right here, right? And then we'll click the red axis for X or U, right? There we go. So now we've built the work plane. We just need to save it. Now, we use TA for our tool block when we were creating OD holder, like you saw in the video, and like we just did on the face tool block where we did just a TA. It's automatically going to create an HA. We also, right, in our other video where we did an OD holder or an ID tool holder, we did TAs. Well, here's a live tool, right? For live tool, we need to save our work plane as TSA, and then whatever you want to call it underneath the underscore is your decision. But that stands for tool spindle attachment. So that tells the spree that when you save this out as a GDML, that there's a spindle right there, and it's automatically going to be on Z, right? But that's a spindle, and now you can put a live tool in there, and a spree understands that. So once I save that as TSA1, I'll select all, select the body, go to File, Save As, and I'll just save this as a holder, and I'll call it radial offset live tool block. Right? Now I can go to my machine setup, tool assemblies, right click station 3 and click add adaptive item. Right? So I built that tool block. Usually I would recommend that you go through and when you create a tool block, you actually ensure it works correctly. So let's go do that real quick on these three. We have 3 good examples to start, and we'll continue on to make a couple more tool blocks. All right, so our OD tool, OD double turn block right here. Let's add a OD turn tool for the main side. So I'll go to TA main, or you can just click the OD up here. You notice how I have HAs and TAs underneath every spot. If I right click and I go to hide adapters, it won't show those positions. So you can decide whether you want to show or hide those adapters in the list. All right, so you can just select the OD block, go to tooling, and we're going to go to turning. Once the turn tool opens up, I'm just going to system default all, go to the first general tab, and I'm going to name this OD turn. We'll go to the shank tab, and I'll make it 4 inches long with a 1-inch F value and a -5 lead angle. Just something simple, right? And I'll come over here to the insert, and I'll put 15,000 tool nose radius is fine. So I'll hit OK. So now we've built a turn tool, right? For our face tool block, we're going to go to turning, right? And we're going to come up here, system default, and I'll call this face tool. Right, and we're going to go to shank, make C4 again, make F1 again, and then put the same -5 lead on it. Now you'll notice that the tool right, is upside down. That's because for this tool to be facing the main and have the insert closest to the spindle, not on this side, we're going to need to make this a left-handed tool. So we're going to go right up here. Let me move this down. Right up here to hand a tool, and we're going to click left. Right, because that's the only way that tool could properly fit in there to machine. Otherwise, it's going to have the spindle spinning the other way, which is fine if that's how you want to machine it. All right, so we'll click OK there. And now for radial offset live tool block, let's just build an end mill. So I'll just say radial, right? I'm just going to click that and then click end mill, and I'll system default this. And I'll name this radial offset, you know, 1/2 inch tool. And I'll come down here to tool diameter, it's default 1/2 inch. Nothing else I really need to change. So now I've got a live end mill in there as well. So let's go build a couple more tool blocks and go from there. All right. So let's make a new layer called third holder. And I'm also going to delete this TSA1 that came from my second holder. All right, we're going to go to File, Import, and we're going to use, let's do an axial live block. All right, so this will come in like that. We'll click yes. There's no issues with the CAD model, which is great. All right, from there, again, if you wanted this tool to be a sub tool, how it mounts in right now is fine. But if I look at my station 4, next MP station, Y up, X to the left, Z to the back. I'm going to go to the part side, Y up, X to the left, Z to the back. So if I want to build this as a main side, I can flip it, right? Now there's two schools of thought. I could create a tool holder for the sub side and a tool holder for the main side and have 2 GDMLs, or I can create one for the main, and then when I put it in and I want to put it for the sub, I can just rotate it 180 degrees by Z inside the add attachment, add adaptive items section in the tool assemblies, and I'll show you that. So it's kind of how you want to program it. I would prefer having less GDMLs, so I always make one and then I'm rotate it around if I want to make it for the sub. So I'm just going to again select the whole model, right click in the GUI and go to copy, rotate, move 180, unchecked, use origin for rotation axis, click OK, and then select the line that goes through the center of the part. Right from here, I just need to go to manipulation on my ribbon, modify work plane. I'm going to choose Z and choose the center of this face. I'm going to choose X and choose the center of this face. Now I just need to rotate the work plane so that Z is facing into the spindle. So I'm going to click the green arc and I'll do -90. All right, from there, that's the work plane we need to create our tool spindle adapter. So we'll click plus and we'll say TSA1, right? Tool spindle attachment point, right? So then I can just left click, right click, left click to select the whole body, go to File, Save As, and I'm going to save it as a holder. And I'll call this Axial Live Tool Block and hit OK or Enter. Now, if I go to Machine View and right click Station 4, Add Adaptive Item, I can go to Axial Live Tool Block. Now, like I said, if I wanted to mount this for the sub, I could just right here in the rotate XYZ, I can come in and put 180 and that would flip it, right? So we're making it for the main, so we'll put that like that. Right? Let's do one more tool block. So I'm going to come in, I'll say 4th holder. I'll uncheck 3rd holder. Delete TSA1. I'm going to go to File, Import. And let's do the live block without an offset. All right, from here, we can run CAD diagnostics. And again, this one's not going to matter too much on orientation because it is square. So whether it's all on center, there's no need to worry about whether it's rotated around Z or not. So we're just going to go to manipulation, modify work plane, and click the blue axis and just move it out to the center or the face of this front piece. Right. I like to take it along that line. There it is. Perfect. So I'll name that TSA1. With the whole part selected, I can go to File, Save As. Go to Holder Files, and I'll call this Radial Live Tool Log. Right. From there, I'll go to Machine Side and go to Station 5, and I can right-click, Add Adaptive Item, and I can just put the Radial Live tool in. Right, and if this is set up correctly, I can just take this radial offset tool I have named and just drag it to other stations, and it should correctly mount. Like that, right? Because you're not, how these are built is they're looking for the same mounting points. Right. So now we can turn that off and we can delete this TSA1. And we're going to create a new layer called Part. And we'll import our part in and just do a simple program using the tools and blocks we just created. Right. So I'm made a new layer called part. I'm going to go to File, Import. And we're going to open in this part right here. So before I click open, I would want to check import as new part. This is the part we're going to program. So this is the part that we want to actually get added to our setup file as a part. So I'm going to click check box here for import as new part and click open. Right, CAD diagnostics, that's great. All right, so from here, I want to put my origin how I want it on my machine, which is usually at the front of my part. So I'll click the front face right here. Now, the thing that's bothering me right now is this model came in solid green, right? And my selection is kind of a green as well. It's hard to see what I'm selecting. So I can select this whole body. And then I can come over here to the properties window. And I can go into the general section and change the color of this model, right? Or if I just want to turn off using face colors at all, I can just click no right there, right? But I actually want to change the color, right? Like that. So now we've got a gray part and you can more easily see when I'm selecting something. So selecting this front face, I'm going to click Align Z. That's going to snap it to the Z. And if I just want to make sure my part's on center, I'm just going to click a cylinder. You could also click that one or any one of these cylinder round ones and click Align Z just to make sure that your part is on center, right? So you can turn it. All right. From there, we're going to go to Home and Part Setup, right? If I had not checked the box to define that this was a part that I was loading in, there would be no geometry in part 1, right? But because I checked that box, everything I was importing in when I selected this model was brought into the part geometry section. If I accidentally had not checked the box, I can just come into the geometry section of part 1 and then just manually select the model, right? We'll hit OK there. And now I want to create a bar. Now, what I want to show you is if you ever go in to create a stock, right? Like this, and the bar will not auto size to your part, that means that your part is not a part. ESPRIT doesn't, you have not selected that model as a part. This is important, right? Because we have 5 models in this program right now, right? Until you tell it which model is your part, it's not going to guess. It's going to wait for you to tell it. So I'm going to hit cancel on stock and go to part 1. And once I put the model in there, and then I click bar, it's going to automatically size to my part. Then I can choose align top. I'll make it 10 inches long. And then I'll do 20 thou on the face. So I did align top, right? And that way I can put a margin on just the face right here. And I'm going to make the outside diameter 3 inch and hit OK. Right? So I'll hit OK. So I've got my part set up. I've got my stock, which creates my combination of a workpiece, and I'll hit OK. Now I can go back to the machine view, and I want to add this workpiece to my machine. Now, if you ever run into the issue where you come in and you can't program anything, right? This is not usually a licensing issue. This is because there can be licensing issues, obviously, if you don't have that license bit. But this is because you don't have a workpiece in your machine setup, right? There's nothing defining where your part is in the machine, so Esprit can't apply an operation to that. So I'm going to click the call it chuck right here. And I'm going to click plus workpiece, right? And now it loads the workpiece into the environment, right? So, well, preview of the workpiece environment. So I'm going to put translate Z5. Now, one thing, I want to see where my part is in my stock so I can make sure that I've pulled it far enough out of the column. But if I come up here to the eyeball right now, my view will not, my visual representation of what I'm loading will not change. This is because the workpiece, part and stock combined, has not been loaded into the workspace yet completely because you haven't hit OK. So this function will not work yet, right? Because it hasn't loaded yet. This is a preview. So if I want to see that, I'm just going to hit OK here, hit OK, and go back and go to the machine view, and I can visually change and see where my part is. Right, so I need to stick it out just a hair more. So I'm going to go to workpiece 1, and I'll make it 6 inches, shift and Z. Right? So now I can see my workpiece is sticking out far enough from my part. Right? So I'm going to go back to the part view, and I can make a new layer for features, and then create my features. Right? So I'm going to go to Features tab on the ribbon toolbar, right? And I'm going to select my part and go to Turning, right? Then I select the axis by which I'm rotating around, which is Z in this case, right? There's a lot to cover right here where you can do all sorts of customizations. You can tell you just want to, you know, what type of works. We've got ODs, IDs, and faces. You can turn off faces or turn it on, and you can turn off everything but faces. You can do cutting side, whether you want it to find only main spindle work or sub spindle work. So we can turn off sub spindle work, right? We're not going to do a sub spindle side. Then you can decide whether you want the grooves to be straight through, right? It's going to create grooves, but do you want the OD to include the grooves? So if you do skip profile, yes, it'll skip. If you do no, your OD will also include the grooves. This kind of becomes important if you're using a tool and you wanted to do an undercut just to preemptively cut some for before the groover comes in. There's also machining zones right here where you can customize where the start and end point of ODs and faces are and grooves. So we're going to click OK, and that's going to build us our OD contour. Let's see, front face contour, right? So we've got all the features we need to continue programming, or at least the turning side. So front face contour, I'm just going to create a rough operation to face the part. So I'm going to go to turning with my feature selected, and I'm going to go to roughing. It's just going to be a single pass rough just to complete the part. I'm going to go to general, system default all. I'll call this rough the face tool. I'm going to choose my face tool, put some speeds and feeds on it, like so. Anything else I need to do? Yep, I'm going to make sure I have everything I want on. Automation, if I want to leave rough stock, I could. I don't plan to. Let's just say I'm going to set a realistic maximum depth. Even though I've only left 20 thou on the face of the part, I always come in and set the maximum depth of cut that I would want that tool to cut. And here's why. If I were to ever go back into the stock setup and adjust that top amount to include more material, right? I would want a spree to show me that it's going to give me multiple passes. Otherwise, I could damage that tool. So I'm going to set a realistic depth of cut for that tool. It could be greater, right? Lead in, I'm going to do a tangent lead in of 25 thou and a normal lead out of 50 thou, right? And I'll hit OK. Right, so now I've got to rough the face. I'm going to go to simulation and I'll click play. I can watch this tool cut the part. Right, so we'll stop there. Now we're ready to OD turn the outside right here. So I'll go to front OD contour. And then I'm going to select turning. And I'm going to rough this one as well. So we only have two turning tools, one for the face and one for the OD. So we're going to combine rough and OD tools here. So we're going to go to General, Default All. I'm going to call Rough and Finish OD. Tool is going to be OD Turn. Similar speeds and feeds. Then we'll go to Strategy. And Rough, I'm going to set the maximum depth of cut to 65 thou. And I'll leave 5 thou Z and X. And I'm going to go back to Strategy and say Finish Pass Yes. So that I get another tab right here for Finish Pass. Let's continue on with our rough pass. I'm going to set lead in again to tangent with 25 and normal with 50. Finish. I'll set to 4,000 RPMs again, and I'll set to a little bit slower speed. Let's do 3,000. Tangent lead in of 25. One thing I want to note, I'm going to look up here and say, oh, wow, there's a radius on the front. Okay. If I did tangent, that means my tool is going to wrap it into this face and then run along the top. So anytime you see a radius, you can still do tangent or you can do normal. But if you do tangent, you might have a witness mark, right? If the face is not done with the exact same tool that you're doing the OD with. So maybe instead I'll use a radius, right? I'll do a normal distance of 50 thou, a radius of 40 thou, and an arc angle of maybe 15 degrees. And my lead out, I'll just do normal of 50 thou. And I might need to adjust my lead in. No, my lead in is going to be fine because on my rough pass, it's not following the contour perfectly. It's following the parallel to axis toolpath. So a tangent would be straight there. So we're going to hit OK. We should see what I would like to call a clean rough. And then you can see that little radius move is going to prevent us from having too bad of a witness mark if we're not using the same tool for the front and the OD. Right. So let's run that in simulation. Now I've got my features manager over here, which shows me my features and my toolpath. And I also have the operation tab right here that shows me my tool changes or my tool calls and my operations. But this is per part. If I want to run the simulation into a specific spot, I should do it from the program view. So if I've already watched rough the face and I just want to watch OD turn, I can come to the link after the tool change, or I can go to the link at the tool change, or the link before, or the tool change itself, and just run simulation from there. All right, so now it's just going to do the OD section. I can also come up here to views and just click ZX. It's going to give me a perfect crisscross view. I can speed this up and slow it down once I get to the finish. All right, so that's still the rough. There we go. So now we're doing our finish pass, and then we'll be ready to do our grooving section. All right, so I'll hit stop there. All right. So from there, I'll go to features. All right. Perfect. All right, now I want to do the grooving. Let's see. So I'm going to select front OD groove, and then I'm going to actually select both of them. I'm going to create what's called a parent operation of where I have two groove features that are going to get two separate grooving operations, but they're going to be controlled by one parent operation. So I can control both of them without having to go in and create two separate operations. So with them both selected, I'm going to go to turning, and then I'm going to go to grooving. I'm going to system default all once it opens up. General, I'm going to call this groove, or you can do grooves. Let's just say grooves. I haven't created a grooving tool yet, so let's cancel that, and we're going to go to the machine view and add a new grooving tool. So let's go to tool assemblies. And we can add another OD block on station 6. So we'll go to add adaptive item and we'll go to OD double turn block again. Here we go. And I'll hit OK. Then I can go to tooling with that OD double block and go to grooving. We're just going to create a simple groove tool. So I'll just default all. I'll call it groove tool. Go to shank. I'll make this 1 inch. So it's just a square. I'll go to insert and I'm going to make the nose radius 4 thou. The width will be a 118. Size E right here. Not a big deal. We'll just keep it at maybe a 0.5, ½ inch. And then thickness. This reset, let's go back to 1. All right, so something like that. Just a representation of our groove tool, and we'll hit OK. So now we've got a groove tool set up in the machine. We can go back to the part view and go back to features manager and go back to creating that parent. So again, we need to select both features, front OD groove, 4 and 5 in my case, then go to turning, and then we'll go to grooving. So we went to turning ribbon, grooving. While that loads, I'll click default all. I'll call this groove. Tool is going to be groove tool. I'll put some speeds on it and then some feed. All right. Let's go to strategy, type of work OD, rough and finish. That's good. Rough. So here's how you determine how your roughing pass is. So one thing to note is we're going to leave, let's say we leave 5 thou, Z and X. Multiple plunge, right? You have a couple options. If you're using a round groove tool, you can do left and right movement, but with this square one like this, you're not going to want to, or rectangle, right? Standard groove tool. So we're going to do a step over. Let's do 52%. You can control some plunge patterns, whether you want to be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. As you can see, there's different options here. Let's see. Plunge direction, whether you want to work forward, go to the center, and then work out, or other way. Now, the finish is the one I think people will get when they're first into a spree, they don't really fully understand yet. If we go to the finish, let's put some speeds on this one. Right. So the finish direction, yeah, you have forward and reverse, or back, yeah. But finish mode, I think, is the biggest confusion because you have a lead in and a lead out on your grooving cycle, right? Your finish grooving cycle, finish pass on the grooving cycle. If you're doing per side, which is entry, do operation and exit in the middle, and then on the other side, you'll get an entry and an exit as well. You're going to have 2 entries, 2 lead ins, and 2 lead outs for each groove, right? That means that when you're thinking your lead out, that's actually in the middle, right? So if you had a really thin groove that did not have a lot of room for your grooving tool, if you did a tangent lead out, you may wipe your groove out. So you always want to think where I want to enter is this end, the edge of the groove. Where I want to exit is how it's exiting in the middle, right? So in this case, I'm doing per side. This is the kind of tool I have. Now my lead in entry, I'm going to do a radius again because there's a radius on my part. If I had a chamfer here, I do tangent, so it just drives straight in. But since I have a radius, I'm going to do radius on my entry, and I'll do a normal distance of 50 thou again, and a radius this time of 50, and an arc angle of 15. Now my lead out is in the middle. If my tool's not too wide, I want to make sure that my lead outs kind of cross over each other a little bit so that I don't get a witness mark in the middle. So I'm just going to do normal tangent and just put in 25 thou. All right. And I'll hit OK. And I should see that the crisscross right here is what I was talking about, where each pass is going a little off past each other to kind of remove any witness mark. And my entry right here will kind of remove If you did a tangent, it would drive straight to the OD and then run along it to get in. If you did a normal, it would come straight to this edge and then come down. So by doing this, you can get a really nice blend on your grooving cycles. So let's watch that in simulation. We'll just watch the whole thing real quick. Shouldn't be, actually, if we're gonna watch the whole thing, let me shorten this cycle up by just changing, let's see. We're gonna go to link, simulation, there we go. All right. So as you can see, just a simple grooving operation here. There we go. All right, so we're gonna hit stop in simulation. So now we need to mill this, and if we wanted to drill these holes, we could as well. So let's do that. I'm just going to select this face and search for holes, right? So I'm going to go to feature and go to hole. Here in the hole finding system, I just use a really large max, a 0 min, and just to find holes pretty quickly and easily. Active work plane only, no. If I did active work plane only, it would only find holes that the Z-axis that's currently shown could do. So we're just going to hit OK, and it should find me this hole, which is a 236 diameter hole, and then this hole, which is a 590 diameter hole. Okay, so I can create those two drills, and then we'll drill those holes. So we're going to go to tool assemblies, right? And I'm going to go to machine setup so I can see what I'm building. And I want to build them, one of them on station 5. That's using the radial live tool block. So we're going to go to right click, and I can right click and go to add milling tool, or I can just click the radial live tool block and go to tooling up here and click drill. Either option. So I'll click drill, and I'm going to system default, and I'll call this the 590 drill. And I'll go down to drill and make it 590. Right. And I want a similar tool for the next station. So I'm just right click and go to copy, right? And I can paste that whole setup, including the radial live tool block and tool, to station 7. Then I can just open up the tool and change the size. So 236, if I remember. And I'll just change the number again. So now I got my 236 drill. Let's confirm 236. Perfect. So now I can just go to simple hole right here. Select the feature, right? In ESPRIT, you select the feature, and then you can program it with an operation. So we'll go to milling, and we're going to go to drilling. We're going to system default all. I'm going to call drill small hole. Drills 236. And we'll say spindle speed at 5,000 for this. 7.5. Right. Use previous stock. Yes, that's just going to control where the start point of my operation is. Because remember, I turn this, so my stock actually comes all the way up to here right now, because I haven't milled the flat yet. Right? I made this side to mill the flat and then move the drill, but for right now, I'm doing the drill first. Right? So I don't really need to do a lot here. There's a ton that you can learn in the drilling section, and a ton of options, which are really cool. So we'll hit OK here. And I should see, right, that the operation started at least above my groove, right? Because it is in the groove hole, right? Otherwise, it would have started here plus whatever clearance I had set. So similarly, I'm going to go to 8 simple hole, the bigger one, and go to milling, drilling. And I'll go to general, and I'll do the 590 drill, and I'll say drill big hole. Starting depth again will be automatic. So you see the start depth It's my fault. The name's wrong, but it's above where the stock is because that's automatically because I selected stock automation, right? All right, so from there, let's see. I want to machine this flat now, right? Let's watch those drill offs real quick, and then we'll machine that flat. So I'm going to select the flat. I'm going to go to Features ribbon, and I'm going to go to Pocket. Right? What I really want to show here is that Pocket is an interesting choice, right? The cool thing about Pocket is if you select the floor, it's automatically going to build you a work plane that's coming up from that floor. You could make your own work plane, or you could do this from the side, depending on how you want to machine it. But I want to machine it with the bottom of the tool, machining the flat that I selected. The Pocket also automatically sees that it doesn't want to violate this side of the wall, right? But these dashed lines tell ESPRIT that the tool can come in and out of that section, right? So with Pocket selected, I'll go to milling, and I'm going to go to pocketing. I'm going to hit System Default All. I'm going to go to General. Operation name is going to be Pocket, or let's just call it mill flat. I'll choose the 1/2 inch end mill, the radial offset one. Right. Strategy. I'm just going to use a simple concentric outpass right here. Let's say incremental depth. We can do full depth. I'll just do a small step over. One thing you want to note is you want use previous stock to be yes. That way it's not machining all the way to the top of the feature. It's only going to machine where you need it to machine. So we'll go pocket, and this is where you can control the lead in and out for your open sections, which is the entire pocket. We'll go to rough tab. Let's choose some speeds and feeds here. I'll do 5,000 and then 4 with a Z speed of 4 as well, 4,000 per rev, per tooth, sorry. And then step over, we'll do 17%. So the entry and exit right here, it's not going to matter. When you're doing an open pocket, it's not going to use that to get in because it has all this space around to machine. It's not going to use any entry mode that you select here. So let's hit OK. And now we've got mill flats, right? So let's watch that in simulation. Right. Now it does have a big clearance there. We could probably adjust that. So one thing I want to show you is that right now we've got our holes being drilled, right? And you can see that they're starting up higher because of the material, right? So let's open this up. Let's make sure we've got use previous stock set to yes. So that way it clearances automatically and you can see that it cuts to the shape. So we've got drill small hole. If I drag this down underneath mill flat, the start depth for that drill is going to be less, right? Because it doesn't see, it sees that there's no material on top anymore. Same thing with big drill hole. Let's rename this, by the way. We'll drag that down so that way it can start lower. Okay. So now if I just turn off the features layer, I can individually see each toolpath like so. And then you can see how the stock looks as well at each point. So we're just going to walk through it. We've got our face, rough and finish, groove 1, groove 2, mill flat, small drill, big drill. let's run the whole thing through simulation and confirm that we have programmed something successfully. I'm going to actually adjust this rough to cut a little bit more, just for time's sake. Let's do 75. All right, speed it up, check for part violations as well. And again, you don't have to view it from that angle. You can view it however you want. I think that angle is a pretty good. It's a view of the kind of the planar section of how the machine is programming the part. So I can speed up the rapids if I want, and slow down the speed. Right, so we've got something where it says, hey, I did something wrong, right? Because it thinks this material is already removed and it's rapiding over it. That could be just a tolerancing issue, right? Because this material is so thin that ESPRIT doesn't see, right? It doesn't see it because it's underneath the tolerance of our stock automation, which we can go into the operations or options and adjust. But it's critical that even though it's under that, it's still going to show you. It might not calculate it when it's doing the toolpath, but it's still going to show you that collision, right? And that's the great thing. It's helping you see things that you might have missed using other software or hand programming it, right?
Something simple we can look at is how the toolpath is working with stock automation. Currently, we have yes set for stock automation using previous stock set as yes, which is going to look at the stock and automatically do all the clearancing. If we set it to trim instead, it's only going to use stock automation for where it's the stock and feature overlap, but it's going to still clearance using the feature. So if I hit OK there, I should expect it to clearance higher because the feature is all the way up to there. If I wanted to change this, I could shift this feature down 1/2 inch and then change the depth to subtract 1/2 inch from the depth. So let's do that. I'm going to select the pocket, right click in the GUI, go to copy, and I'll say translate, and I'll use X here, and I'll say -0.5, and I'll say OK, and then I can take 500 thou out, make that 4, and now my feature looks like that, which should look like a good stock representation. So if I just right click mill flat and rebuild, now it has a consistent clearance. So then we can watch simulation from the beginning and complete that. Just to check for any collisions, part violations, or anything we may have missed while programming. I'll let it run all the way through the program. So now we have a consistent clearance, which is nice, while it's still taking into account where there's stock with our entries and exits, as you can see. Final drill, big drill, there we go. That completes this here in the webinar. Thank you very much for coming, and I hope you guys have a great rest of your day.